So welcome back to the last topic of section 8.7 and actually the last topic for chapter 8. And then tomorrow we will move on to chapter 9. So for this topic, we are going to be solving an exponential equation by using logarithms. So we're going to be using logarithms because we won't be able to find, this trick is used when we cannot find a common base, and as you'll see it in our example. And as you can see, we're just going to do one example because most of the problems is essentially the same, right? So I think one problem is sufficient. So I gave you some steps and I have an example, so let's just go ahead and do the example. Our directions say solve for x, and then write the exact answer using either base 10 or that should say base e logarithms. So you can do whatever you want. You can choose to use log or you can use natural log. I like natural log because it's less letters. I know it's just one less letter, but nonetheless, it's less, right? So when you use natural log or log, it doesn't, you'll still get the same answer. Like if you don't believe me, put in your calculator, you can try like log of 5 and then try natural log of 5. And then you'll see you will get the same solution, right? So going back to example 1, so I want to solve 2 to the x plus 3 is equal to 7 to the x, right? And we want to solve for x. So the first thing when you see exponential equations, you should always try to do topic 2, like what we learned in topic 2 first. You always want to see if we can have a common base, right? But over here in example 1, it's we can't. Why? Because we know 2 is a prime number, 7 is a prime number. So we know that we can't put anything to a power to make it a common base. All right, so since we can't make it into a common base, what are we going to do? So step 1, it says isolate one of the exponential expressions in the equation. So over here, both of them are isolated, right? So fine. But if, say, this was like minus 7 to the x equals 0, then I want to move that 7x over, right? We just want to have one exponent on one side, right? And then step 2, we're going to take a logarithm on both sides of the equation. You can use log. I'm going to use natural log, right? And then for step 2, why are we going to take the logarithm? So keep in mind we have this lovely power property, all right, that says if we have a log and then it's like to a power, we can bring that power down and make it a coefficient. So that's why we like to use log. Like when I see this, I think of logarithm in order to get that variable out of the exponent, right? So I'm going to take natural log to both sides. So I'm going to take natural log of 2 to the x plus 3, and I'm going to take natural log of 7 to the x, right? So now I'm going to use the power property. So this is going to become x plus 3. Make sure it's in parentheses because this is not the same as x plus 3 natural log of 2, right? Not the same because just that means the 3 is just attached, all right? So this whole thing is attached to our logarithm. And this is x natural log of 7. Right, and this was property 7. Right. So what is our next step? So I kind of skipped ahead. So step 3, use the power property. We did. So now step 4, so it's kind of vague. We want to solve the resulting equation from step 3. So how are we going to solve this? Remember, what is our goal? Our goal is to solve for x. So I'm looking, I see an x here, and I see an x here, right? So our goal right now is to get all the x's to one side of our equation. In order to do that, this x plus 3, so let's attach this log of 2. So what are we going to do? We are going to distribute this. So then I'll get x natural log of 2 plus 3 natural log of 2, right? And this is x natural log of 7, right? So I have 2 terms here, 1 term here. I have x on both sides. So what I'm going to do is I'm just going to subtract this x over x natural log of 2. Right? So when I do that, I will get 3 natural log of 2. One thing here, I cannot subtract these. Right? Cannot do it. So this is 2 terms. Right? They don't have the same argument. Right? Since they don't have the same argument, I can't combine them. Right? So now we're so close. So I have an x here and an x here, but I just want one x. So how do I get this to have one x? If you're thinking factor it out, you are completely correct. So since they both have an x in common, I can factor that x out. So I'm left with natural log of 7 minus natural log of 2. Right? So last step, we're very, very close. Remember we want to get x by itself. So I'm going to divide this to both sides. So what do I get? I get 3 natural log of 2 over natural log of 7 minus natural log of 2. And that is equal to x. Right? So, and it says write the exact answer using base 10 or base e logarithm. So we're done. Actually, almost done. So I have this 3 natural log of 2. How can I also rewrite this? I'm actually going to do it here. So 3 natural log of 2, that is also 2 cubed. So this becomes natural log of 8 over natural log of 7 minus natural log of 2. Right? And this is our solution. So that is it for chapter 8, and then tomorrow we will start on chapter 9. So if you guys, like always, if you guys have any questions, please email me and reach out. But if not, I will talk to you guys tomorrow. Bye.